As per Lewis concept, acid accepts a pair of electrons. Now, if you look at carbon monoxide, cyanide ion, nitrosyl, and if I write the molecular electronic configuration, carbon has 6, oxygen has 8, there are 14 electrons. You can see that the antibonding pi star level is vacant. So in this vacant position, antibonding pi star level, electron can be donated. Electron, if it is donated here, it will be donated to carbon monoxide because these antibonding orbitals are present in carbon monoxide. So carbon monoxide, cyanide ion, nitrosyl ligand, they can accept pair of electrons in the antibonding pi star level. So they are called pi acid ligands. Acid means Lewis concept acid. Now if you think about burning of carbon in a closed chamber, it results carbon monoxide. There are many incidents that during cold days, some of the person, it is there in the story or in news, that burning of wood is done to make the room hot, and as the room is closed, carbon monoxide is formed, and the next day you hear that the person inside the room has died because carbon monoxide gas is formed by incomplete combustion because the room is closed. Now carbon monoxide is 300 times faster in binding to hemoglobin, the iron atoms, which is the central atom, than oxygen. Similarly, we have heard during the liberation tigers of Tamil Ilam, LTT terrorists of Sri Lanka, whenever they were caught, they took cyanide and in a fraction of a second they died. This nitrosyl, if you talk about nitrosyl chloride, this is very hazardous gas, NO is produced, which creates cough. Irritation is there. So all these three, they have antibonding pi star level, so they can accept a pair of electrons. So all of them is pi acid ligand. Now normally if you talk about Cl minus, ammonia, water, they forms bond. The ligand will donate electron towards the central metal. This is called sigma donation. Or if you talk about ammonia and metal, sigma donation. This is also sigma donation. But this type of ligand is slightly different. If you talk about iron, plus 2 suppose, it is D6 configuration. D orbital capacity is 10. So 4 vacancies there. So some of the orbitals is filled up. 6 electron is there, 4 vacancies there. And suppose I write the filled orbital like this, just for understanding. Suppose this is the filled orbital and this is the vacant orbital. This carbon monoxide, if you consider it as a ligand, it actually sigma donates towards the central metal. That is the normal tendency of a ligand to donate electron towards the central metal. Now, this carbon monoxide, you have seen that antibonding pi star level is vacant. That is the thing I have told just few minutes back. This antibonding pi star level is vacant. So once this sigma donation is done, which is the normal tendency of a ligand, is the sigma donation, the filled d orbital back donates, resulting in the increase of bond order, which is not possible with a normal ligand. So once the bond order is increasing, once carbon monoxide or this pi acid ligand binds with the central metal, you cannot remove this ligand easily. This is called synergistic effect. Synergistic means acting together. Sigma donation, back donation. It is happening together. So this effect in general is called synergistic effect.